equilibrium, conditions in terms of virtual work. Equilibrium, we now express the equilibrium conditions in terms of virtual work. First for a particle, then for a single rigid body, and then for a system of connected rigid body. At first, equilibrium of a particle. Consider the particle or a small body as shown in the picture here. Small body in the picture which attains an equilibrium position as a result of the force in attached springs. If the mass of the particle were significant, then the weight mg would also be included as one of the forces. For assumed virtual displacement dr as shown in the picture here, delta r, infinitesimal virtual displacement delta r, virtual displacement of the particle away from its equilibrium. Away from its equilibrium the total virtual work done the particle is, we have various forces, and as we said, if we have a significant weight m, we should consider also mg here. So du delta u f1 as a vector for delta r plus f2 delta r plus f3 delta r, and if we have various forces plus f delta r. We now express sigma f in terms of its scalar sums and also delta r in terms of its component virtual displacement. In the coordinates, we have this relation delta u sigma f x I f y j f z k delta x I delta y j delta z k delta u sigma f x delta x sigma f y delta y sigma f z delta z. And we know the summation of forces is 0, which gives and also gives the result that delta u equals to 0. is therefore an alternative statement of the equilibrium conditions for a particle. This condition of zero virtual work for equilibrium is both necessary and sufficient, since we may apply it to virtual displacement taken one at a time in each of the three mutually perpendicular directions, in which case it becomes equivalent to the three known scalar requirements for equilibrium. The principle of zero virtual work for equilibrium of a single particle usually does not simplify this already simple problem, because delta U equals to 0 and sigma F also equals to 0 provide the same information. However, we introduce the concept of virtual work for a particle so that we can later apply it to systems of particles. Equilibrium of a rigid body is the next section.